The Cambrian Explosion, a short fuse or a slow burn? Before we go into any detail, let's start off with the basics. What was the Cambrian Explosion, and what do we mean by short fuse or long burn? The Cambrian Explosion, also referred to sometimes as the Cambrian Radiation, was a period in time occurring roughly 540 to 530 million years ago. In the 1990s, it was common belief in the scientific world that during this time, evolutionary invention occurred at incredible rates, resulting in an impressive array of body plans. As indeed most of the modern animal phyla seen today can be found within the explosion. Now, short fuse. By this we infer an explosion of radiation during this period in time, meaning that the organisms found within the explosion originated there and were not present in any earlier age. On the other side, we have the slow burn, inferring that although evolution was still happening at a fast rate, it was not to the scale of the explosion, so to speak. Instead, it could have happened at a more constant rate over a longer period of time. But now we can get into the evidence supporting each side. Many scientists believed in the short fuse or explosion due to the fact that this is what the fossil record mainly represents. There is little fossilized evidence of organisms seen within the Cambrian explosion being present at any earlier time. However, is this due to the fact they did not yet exist? Or due to factors such as the evolution of the skeleton, which fossilizes more easily? Or even changes in sea climate, again allowing fossils to persist? There are also trace fossils available, both in the Cambrian explosion and beforehand. However, the traces found in the early Cambrian rocks are increasingly more complex and diverse than those of older origins. In the period before, known as the Ediacaran period, traces were horizontal to the surface floor. In the Cambrian period, organisms began tunneling vertically and exhibiting different behaviors. This led to one of the many hypotheses behind the rapid radiation, known as the Cambrian substrate revolution. Here in the picture, you can see that the vertical burrowing has resulted in the organized structures of the seabed turning into a more soupy one. As water and oxygen now have access to new sediment layers, ecological niches opened up, allowing for more speciation. There are many more hypotheses backing the reality of this explosion in diversity, from the light switch, where development of eyes led to an evolutionary arms race between predators and prey, or that the ancestor of all modern organisms reached a level of complexity where even the slightest changes in developmental pathways would result in staggering changes in body plans, all of which seem to have been now locked in place, as no new ones have arisen. Unfortunately, there isn't enough time to discuss all of these in detail. More recent developments in this field, however, point to the idea of a slow burn. One of these major driving forces is the generation of a molecular clock. We can take two extant organisms. For this example, we will use a deuterostome and an arthropod. We can then look at the genes that arise in both of these organisms, and we can see how many mutations have occurred. Under the assumption that these changes in DNA happen at a constant rate, we can track back through time to find their common ancestor. If, following the common belief that these ancestors originated in the Cambrian explosion, this is where we would expect these two lineages to meet. Early clocks, however, show these lineages meeting slightly beforehand, in a period known as the Ediacaran. Newer molecular clocks, which do not follow the rule of a constant rate, but instead use other forms of calibration, such as the fossil record, to depict the same lineage, that of arthropods and deuterostomes, originating in the early Cambrian explosion. So although the molecular clock hypothesis provides food for thought on pre-Cambrian existence of ancestors, it is not yet conclusive evidence enough to disprove the idea of a Cambrian explosion. Going back to the fossil record, there are now fossilized soft body remains of large Ediacaran fauna, again showing that the explosion of life within the early Cambrian age may not have been as abrupt as first believed. As you have seen by now, it is not quite as simple as giving a definitive yes to either side of the argument, where it is clear to see that the early Cambrian was an important stage in evolution of animals on Earth, and has clearly shaped the way to the modern age. The importance placed upon such a short period of time may have been slightly exaggerated, and in reality, Although still short in terms of evolutionary time, it may have been a slightly longer fuse than first believed.